All right. Welcome to episode 22 of Roid Rage. We have one of our engineers, Wesley, today, who is an integration and test engineer. He's worked on Odin. He's also working on Vestri. And we're going to talk about vibe testing today, which is different than vibe coding. And I'm going to ask you to explain the difference. But before we start, tell people who you are, how you got here, and what is an integration and test engineer.
Hi, I'm Wesley, structures integration and test engineer.
Yeah, structures, chap. Don't get that shit wrong.
Yeah, for some reason I have a really long title, but I went to Arizona State. I worked as an intern at a couple different places doing some weird things, like making Botox, then making
Hold on, you made
lighting
Botox?
fixtures.
You made
What?
Botox?
Where?
Yeah, a place called Mertz in Wisconsin. I used to make Botox.
Did you try
I was
it?
a manufacturing engineer. No, we did get discounts though. I never ended up using any of it though.
Botox is like one of the most toxic substances on earth,
I
right?
also-
At least from that little shitty chart I saw on Reddit, it was.
And I also didn't realize that, like, once you start taking Botox, you have to continually take Botox. You
You
can't
do, yeah.
stop, otherwise.
It creates voids in your
Yeah.
body. Yeah, it just deteriorates over time.
Oh, dude. So this shit's gonna cost me a lot of money to fix these wrinkles.
Absolutely.
And it might be worth it.
Yeah. Then manufacturing engineer intern for lighting fixtures.
Okay.
For like prisons and psych wards.
Okay.
and then went to
Who hired you? So that's what you did your interns as? Then you came here?
and then manufacturing project engineering and test engineering intern at Namo making rocket launchers and rocket boosters.
Okay, so at least whew.
For artillery
Okay.
rounds. Yeah, and then found out about this place through a class at ASU called Space Entrepreneurship and Business. And
How'd you find out about us at a class? What?
So Jose came and spoke at the class at ASU about, I guess it was about his path and then what he's doing currently. And so basically I kind of went up to him and I was like, hey, you guys sound really cool. Could I get a tour? And I was like a year and a half out from graduating,
Okay.
but I got a tour back when the first ever landing legs were being made, saw them break a couple times, and thought it was still cool. So I contacted back right before I was supposed to graduate and got an interview to come here.
Okay. That is not the journey that I expected to hear.
Yeah, no, it's a
Getting
very
here.
weird one.
I'm really glad I got to like hear about that real time with everybody else here. Okay, cool. So you are here now. You are a structures integration and test engineer. What does that mean?
So currently I do structural design.
Okay.
So I'm working on the solar arrays, but that also means that I go to all the tests for the structure of the vehicle. So we have the thermal team and we've got the mechanical team under the structures team as a whole, which means that I go to TVAC, I go to vibrational testing, and then whatever else is in between.
Okay.
And then I also build the vehicle itself, integrate it all together.
I like how we talk about this as like the structures team has the mechanical breakdown, thermal breakdown. To be clear, that team is 3 people.
Yeah.
So it's not like really what you are is both.
It is not 3 people.
It's more than 3
It's
people.
more than 3 people.
Yeah, it was 3 people when I got here.
It's 3 people. We had 1 start today, so it's 4.
Yeah. That's not 3.
It was
Okay,
5.
Okay, sorry. It's 5. Yeah, it's fine. I got it wrong because someone started today.
We peaked at 5 at one point.
Yeah.
Fair enough.
Okay. So you play a role in testing. So like you talked about 2 different types of tests, thermal and vibration testing. I think for today we're going to focus mostly on vibration testing. Sort of in the name, but like give us a sense of like what is vibration testing and what are we actually trying to replicate here?
So vibration testing, we put our vehicle on this big shaker plate and we shake it to the environmental conditions of launch loading. So basically, as you launch, the whole entire vehicle vibrates quite a bit, and
Okay.
those loads are actually stronger than the launch loads of like the G's that you would think of when you're on a vehicle. Like think about sitting in a car and accelerating. It's worse than that just
Okay.
from the vibration of the vehicle itself. So we have to test in every single axis and make sure that we are not falling apart. We're not turning on accident. We're not deploying parts of the vehicle. We're staying electrically connected kind of a workmanship of sorts test.
Well, it's actually a whole bunch of detail here we can dive into. I mean,
Yeah.
first piece of detail is you don't just vibe at one frequency. So you'll vibe to different levels at different frequencies. And usually we'll do two different types of tests during a vibe test. We'll do a sine sweep, and then we will go to levels of amplitude in certain axes.
So there's three. There's burst, there's sweep, and there's random. So random is the closest to launch, where you have an extended period of time along all frequencies and various amplitudes. And then sine burst is where you're at the highest amplitude, close to your excitation mode. And that is where you'll experience the largest loading. And that's where we experience some failures on Odin. And then sine sweep is just to make sure that your frequencies are not you're not getting amplified at certain frequencies that the vehicle will see.
Got it. And how long are each of these tests? And like you mentioned, this a lot of G's. How many G's are they experiencing?
So it depends on your vehicle.
Okay.
Depends on the payload mass, but yeah, it also depends on where you are on the vehicle as well. Like our solar arrays at the tip saw 100 Gs on
Wow.
Odin, whereas the center of the vehicle is at 10.4,
Got it.
depending on the axis as
So
well.
the entire vehicle doesn't actually experience the same load at that point. Actually, it's a wide range of loads there.
Yeah, it propagates through the structure differently depending on where your accelerometers are. So
Okay.
we place accelerometers all around the vehicle, and then we have to backtrace those to the CG, the center of gravity.
And like, what are you trying to catch here? There's the obvious of like, oh shit, that just cracked. Like, what else are you looking for here?
Yeah, so I mean, there's the requirements from SpaceX. So your electrical inhibit can't turn, it cannot release. So
Okay.
you can't turn your vehicle on, because if you turn your vehicle on, you might thrust, which could damage other things. You might deploy, which would also do the exact same thing to yourself and to others. And then you want to make sure that when we do finish those tests that we're able to turn on, and we turn on cleanly, because you can also break electrical connections. Like crimps can fail, solder cups can fail, boards, if you don't secure them properly within your avionics boxes, could also.
I mean, anything can fail. It's part of the test, right?
Yeah.
But I mean, to break this down a little bit more, what we do is what's called a functional test before and after each vibration test we do. And a functional test will check for things like, did the inhibit work? Can we still actually turn the spacecraft on after? Does the flight computer boot up? Did anything on the boards break? Like, we have this whole series of tests we go through before and after, because one of the hardest things in testing at any level, whether it's TVAC, whether it's vibe testing, is actually knowing why you failed. So we could do this whole set of all these tests and all these different access and return and rotate the vehicle. And I think a full Delta qual will take about 3 complete days for us. And we don't want to test it at the end and say like, oh, it broke.
Yeah.
That's not going to be helpful. We want to know where it broke and what level it broke and what orientation it broke. So kind of understanding and breaking that down is pretty critical. And then we have to meet the regulations by SpaceX, which is also no fundamental frequency below 40 hertz on any part of the vehicle. And the whole like nothing falls off. I don't know if that's actually written in the payload user's guide, right? You can go look this up, but essentially it says like, did anything break on your spacecraft or fall off? And like you pointed out to, one of the reasons we got divorced from our original vendor from Odin is because during the first vibe test, a piece of it fell off. And that was just such a clear like, oh, okay, something is hugely wrong here. We need to go reevaluate this. And it turned out to be like, yeah, we have a bigger problem, and we moved on.
Yeah, that was the original bus. When we even redesigned, we had another failure on the solar arrays that we had to take a part out. And that took a day or two to actually root cause and figure out what the problem there was, and then find a solution as
And
well.
go into that. I mean, that was on
Yeah.
the D cubed.
Yeah,
nut.
so the D cubed release nut is basically this part that releases our solar arrays. It holds the solar arrays in while we're sitting on the vehicle, and deployable appendages cannot release
Yep.
on the vehicle. So we went into Vibe, and we ended up seeing that one of the arrays started swinging around, while I was going. So we restowed it and then kind of sat around, like made sure that we could pull on it and it was still retaining. So we figured that the release nut was actually fine. And then we retested and it happened again. So we stopped testing immediately. We went back, we scheduled a call with D Cubed in the middle of the night because they're in Europe. And one of their suggestions was to put a spring in to actually help with your preload to release the mechanism itself. And that spring was actually seeing excitation in certain frequency ranges where uh, we ended up pushing the preload past the limit. So we took that little spring out and we retested, and all of a sudden it started working. But we came back, we tested deployments without the spring, and it seemed like it would still deploy fine. So we continued with that solution.
So I guess let me ask this question. How many times did you test Odin? And in a perfect world, how many times do you go through vibe test?
So we tested the solar arrays once incorrectly. That was my first week here. And then
Way to fuck it up.
yeah, thank you. And then we tested the vehicle 3 or 4 times.
Tested it 3 times.
3 times.
Yeah. What 2 of them were really our fault. So one of the things in the payload user guide is that it says like, hey, cool, you tested your spacecraft, don't touch it. And if you want to go touch it, that's great, but you have to re-go through a vibe test. And so one of the things we had to do is when we had the failure of the, there was a part called the overvoltage shunt that broke on the back. And so when we did a test of the solar arrays, actually, we saw an overvoltage go through and we essentially lit our spacecraft on fire, which is always a fun one. And then at that point, we really don't have a choice but to open up the spacecraft and fix it. So we knew when that happened, we were going to go back into a vibration test for workmanship to make sure that was good. Well, that is a very different vibe test, right? It's a much lower level vibe test to prove that we've already proved that the spacecraft can handle the loads of launch.
Yep.
Now we need to prove that we assembled it back together correctly and it's not going to fall apart. That's essentially what that test was doing.
Yep. All right. So that's how we did with Odin. How like do we have a different approach as we think about Vestri? Like and where I guess orient people, like where are we in relation to our upcoming vibe test?
Yeah, so we already did one subassembly vibe test on the solar arrays,
Okay.
and we really pushed those past their limits. We were explicitly going there to fail them.
Yep.
So
why was that?
we just wanted to see where the failure mode would be, if it would be at appeal failure from the bond line between 2 carbon pieces, or if it would be the structure itself, if we were actually matching what our analysis said.
Got it.
And we ended up seeing a failure at the bond line, which just means like add a little piece to hold that
Yep.
on and continue on. But we actually have since fully redesigned the solar arrays and the entire structure is completely different. So we're going to continue going forward towards a primary structure vibe. So we won't have all of the avionics in place or anything like that. We are going to throw mass simulators in, pretty much just blocks of metal
Yep.
that simulate the mass at those locations and mounting points, and we will throw it through the entire gauntlet of a vibrational test and see if the structure holds up and if it matches our analysis.
But that's the big part. We're trying to correlate our analysis to what we physically build. And the challenge with Vestri compared to Odin is Odin had a much stronger structure. Odin was overbuilt. We had such a small amount of time. We didn't want to waste time thinking like, oh, are we qualified? Are we going to meet 40 hertz? Are we going to survive? It's really easy at that point to sacrifice a couple kilograms of mass to make the structure more beefy. We're not doing that on Vestri, right? Vestri has to be a lean, mean machine with a lot of delta V. It has to have a lot of thrust capability. And so we need to build that thruster pretty thin and pretty light. And if you look at the differences, like them next to each other, the base plate on on Vestri, I believe it actually weighs less than the base plate on Odin.
Yeah, it definitely looks like it has a lot more holes in it.
Yeah, I don't know if it actually does, but like it's bigger, but it's thinner.
Yeah.
And like it is built to be much more a kind of sports car variant of what Odin was. And because of that, we want to make sure before we assemble everything and we're all ready to go that like, hey, our analysis is correct and we're correlated correctly.
Yep. Okay.
And so that'll be one of our first big tests we go into is just, does the structure and the solar panels work? right? Is our analysis correct? The solar panels are also really big and mounted in a way where they have pretty big lever arms.
Yep.
So they're kind of like floppy ears hanging off the spacecraft. And like, we got to hope we got that right? We got to hope that that's the right thing. And we want to test it as early as possible in case we didn't.
Yeah, and last time we also made everything out of metal, and it's pretty easy to simulate metal. However, we're going to sandwich panels for pretty much everything. And one, composites are hard to correlate to real life.
Why
So
is that?
it's just a much more complex system, depending on how your carbon fiber layers are actually
Yeah.
layered together. That's called the ply schedule. They perform pretty differently in bending, and then you're also layering together quite a few things. So on top of that, you have a thermal analysis, and you have adhesive layers in between your face sheets and your sandwich,
Yeah.
your core. So there's kind of a much more complex buildup to what the primary structure is for every single component that's on Vestri. They'll all have different material densities. They'll all have different material thicknesses. So it kind of propagates a little.
It's just really hard to simulate. We have, I mean, our solar panels are carbon fiber sandwich panels that are aluminum honeycombs. Our structure panels or side panels are aluminum face sheets with aluminum honeycombs. And then our base plate is a solid piece of aluminum. And so like those are three different types of materials that we have to get right. And like Wesley said, the bond lines, how you think about like it's very difficult to get this all. And analysis tools are pretty advanced at this point. Like we can get actually pretty close, I think.
Yeah.
But let's test it early. I think that's the real thesis we've talked about before. The company is like test early. It's not about being okay with failure. It's about getting to test as soon as possible. So if there is a failure, we can correct it in time.
And what do you find that like actual testing catches that analysis tools don't often catch?
I mean, that spring would be the perfect example of what we didn't catch early.
Yeah.
We didn't realize that would be we saw a mode where that would be an excitation mode, but we didn't necessarily see the spring itself would be in that exact same frequency plane where we were seeing way higher loads at the release nut than we thought we would.
Yeah.
What also testing does is something that maybe seems a little off is in order to test the whole structure, we actually have to build the whole structure. So what testing does is act as a forcing function for us to actually go pencils down and build a solar panel and make sure it's done in time and build the brackets and figure out how to manufacture them and glue everything together and actually do the work. And if you don't have that testing milestone early, you'll get into analysis forever, right? I think this is what we hear a lot in new space that I think is very different. It's like we want to put pencils down and go test to see how these things perform. It's a fine balance, right? You still have to do the analysis. You still got to understand what you're doing. But you also got to drive towards actually doing it. And like, we can't spend 10 years designing the perfect spacecraft. Like, let's go build it.
Yeah.
You actually also get to see if parts fit together properly, because it's really easy to, in CAD, make a part that looks like it's going to fit together right. And then as soon as you go to manufacture it, it's pretty much impossible.
How is that different than other places?
So bigger places, they have a nice machine shop where they can turn around these things really quickly. And we're starting to bring that in-house. But with Odin, we didn't have anything in-house. So a lot of those parts were pretty complex, and we bought them all from machine shops so they could turn it over to us, with really experienced people and techs and machines. We have our 3-axis, and we have a bunch of people that don't really know how to run it. So we're kind of breaking bits and moving forward as we can and learning how to make parts simpler, which is actually just going to help us in the future as well.
Yeah, and especially because we're bringing a lot of this in-house, and we're probably going to do a little bit more testing than we did in Odin. Like, what are you personally learning on Vestri that you didn't learn in Odin?
I mean, I was not here for any of the design part of Odin, so
good cop out. You broke it. Solar panels were broken on.
So basically, what I just
watch.
heard is like none of that shit was my fault.
Yeah. I would say the burnout was probably a little bit of my fault because I put it together and I didn't notice that I broke that shunt off. But
wait, you caused the shunt to break?
I mean, it was
okay. Let's update the champion power thing. Actually, this was
it was sticking out of the bottom, and like a lot of that integration. What we learned is make it way easier to put together and take apart, because when things fail, we had really slow turnaround.
And to be
with
clear,
it.
we actually put a lot of effort into making Odin easy to disassemble. That's why you could flat test it, right? And that was already an optimization.
Yep.
And what we realized, like, that wasn't far enough. And you've seen me push really hard on Vestri to say less wires, less things, like make it as simple as possible. Same we talk about parts, like assembly matters a lot.
Yeah, there were many days where I was sitting in there just holding up the RF deck so that we could disconnect it for like an hour, and I'm sitting there shaking, sweating, trying to hold it up. But it would be very nice if we could open up Vestri and be able to work on it with a quicker turnaround.
Vestri has a big hole in the side of it called a missing plate. So it's really easy to work on. That's the plan.
It's intentional, right?
Yes.
Yeah.
It is intentional. Yeah. Big piece of MLI will go over that.
Yeah.
But
That is why if you ever look at a picture of Vestri, the front face is not missing. It doesn't exist. And that is simply so we have access to everything with a hand and a wrench without having to disassemble any part of the vehicle. That's the theory. That's what we're trying to aim for.
Got it. Anything else that you're learning in the transition?
Difficult question. I would say that we could definitely have tested more. We did a lot of full vehicle tests. It would have been very nice to do some sub-assembly tests and do them as early as possible. That's why we're trying to get our TVAC up and running. We already have 3 tests for the solar arrays in progress. Actually, 4 tests for the solar arrays in progress. Yeah, just test as much as you can and as early as possible.
What are the blockers to testing more frequently?
Spike ball?
Spike ball for sure.
Are you still? Do you know Wes is like a pro spike ball player? He's like
I didn't
on
know
the
he was
circuit.
pro. I've seen
Are
a
you
lot of
pro or
spike,
amateur?
spike ball like apparel around.
So technically premier qualified. That's not
Okay,
really
I
going to tell
didn't
you
answer the
much.
question. Are you pro or not?
No, there's another league above called Pro. There is another new league called the Pro League, which I also am going to be a part of. So if you call that pro, then sure.
Is this violate our employment contract? Like
I don't know,
if
but
the
it's
CIA
the
says
best
you can only
answer
Yeah.
that I've heard on this podcast in a long time.
Is that what? Yeah. I don't, okay.
All right. So other than spike ball, what are blockers?
The blockers are honestly just pushing out designs and manufacturing as fast as possible right now. We've been machining a base plate for quite a bit. It would be in our best interest to start getting some of those other assemblies built up so that we can start testing them. Like the solar arrays, it's very nice to have a company go and make those because there is a lot of testing associated with any type of mechanism. When you go through thermal cycles, your tolerances all change because of thermal expansion. We're going to have to test those hinges cold and hot, make sure that they actually deploy. We're going to have to test them on a bigger deployment system, hopefully a little bit better than Odin's quickly put together 3D printed deployment system. We'll have to do we'll have to make sure that we actually get solar input. So we're building a big light fixture that simulates the sun to see what our solar input matches the curves of our vendors that we're purchasing our solar cells from. And then we have the homing mechanism that we're also building in-house. So a lot of stacked up things that go into one tiny sub-assembly that we're going to have to test all together that we didn't have to test with Odin. So we're definitely taking a lot more in-house, but it'll allow us to iterate a lot faster for the next one.
Okay. Let's make a bet between the two of you. Over under a number of tests that Vestri goes through before they launch. What's your number?
Vibrational?
Yes.
Yeah. What do you mean number of tests? There's a lot of tests.
Number of
this is
vibrational tests. Sorry, we'll limit it to that.
I mean, Vestri as a whole will go through one vibration test. Well, whether we go through multiple on the structure,
Yeah.
I hope not, but I'm not going to bet against it. Like, I think that's when you're running really thin margins intentionally. Like we are running very thin margins as a company. That's what we have to do on the structure, right? We're so mass constrained that we can't just have 50% gross margins on a structure to build it. And so what does that mean? It means somewhere along the line, we're probably directionally wrong and we'll have to retest and we'll see where that becomes. Obviously, if our base plate fails, that's a pretty big fuck up. And we're probably retesting again for sure. If the tip of the solar panel hinge gets bent a little bit, like, well, we may just go fix that and go into the full vehicle test. I think it'll really depend, but I don't I don't want to bet against not testing more. I think that's the wrong way to think about it. I want to bet that we are going to be able to complete it on a quick enough timeline where we'll have the option to test more if needed. And I think that's really the goal we're going for.
Got it.
Yeah, I'm probably gonna sit around 3.
I was saying, we might have a new king
3
for
complete vehicle?
Complete. Well, we'll have the structural test. I'm counting that. And
We have to
then
do a vehicle test, so that's 2.
I'm gonna guess 1 penalty. That's gonna be my best guess. But I think we'll have sub-assembly of the RF deck so that we could test that downstairs pretty soon, and then we'll have all these other components actually built up so we could flat test them. That's definitely one huge takeaway from Odin is flat test.
Yeah.
Because
Remind people
we
what a
jumped.
flat test is, just in case they don't know.
So basically, we take all the panels of the vehicle, we lay them out literally flat, and then we test the entire vehicle functionally. So we can take it apart and check connections. We can check that our harnesses are made properly because we definitely had a lot of swapped pins, and that can come from a multitude of places. That can come from drawings. That can come from just the assembly of them. We're running through thousands and thousands of connections. So, yeah, just running functional tests completely flat and seeing what breaks and what doesn't.
Cool. Anything else we should know about vibe testing?
Vibe testing looks really cool in slow-mo, so I hope you get to see the videos pretty soon. But yeah.
I think the important thing to know about vibe testing is we also don't do it here. Vibe testing requires some pretty big drum machines that we go out to, and we'll go to probably Oxnard again to do it at NTS. We go out of house, just like a lot of companies do for vibe testing. It's very expensive and probably not the best use of our time to actually have a vibe table here on site that's calibrated.
How big is a vibe table?
I mean,
they're like
about as big as this room, probably.
It's actually not that inaccurate. It's pretty dang close to the size.
So for our viewers who can't, or for our listeners who can't view the room, how big is this room?
12 by 10.
Something like that. Yeah.
Yeah. Okay.
Feet. So they're not very big, but I mean, they're pretty complex and they do have to be calibrated. And I think what's actually more important is the techs that understand how to correlate the accelerometer measurements and where to put them. Like that is a huge benefit of bringing this out of house. Like it's just at the volume we do this, which is it's like on the high end of Vestri, we're going to do this 4 times over the next 8 months. Like every other month, I'd gladly pay the fee to have somebody go do this and help us with it than anything else. It's just, even with the shipping, it's not really worth something or something we'll look at vertical integrating anytime soon.
Yeah, so I guess like as we look forward, and at some point we're going to get into manufacturing and number of vestries per year. At what point, like, do you have a number of vestries that you like is a threshold before you bring this in?
I think as soon as we start doing dedicated launch and we're building multiple spacecraft on a rocket, that's absolutely when you start to look at scaling up all of the testing in-house, right? But as we go through this first phase where we're looking at these demo launches where rideshare, it just doesn't make a lot of economical sense to go spend what equates to essentially $1 million on a vibration table to have it installed as a CapEx hit to this point in time.
Yep. Okay.
Also, God, how much nicer is this podcast without Robin?
I
just want to say that as a whole, like it's much nicer and much cleaner. People are very friendly.
We miss the dad joke.
Yeah,
though.
that's what I was saying.
Yeah.
I was gonna miss a lot of dad jokes in this podcast without him.
If either of you, Rachel, do you have a good dad joke for us?
Oh my God, no.
I'm gonna call bullshit on Rachel. I feel like she has a good list of dad jokes that she just does not want to put out here.
I mean, she listens to all of them, so she
listens to all these multiple times to edit them, and I don't know why she edits them, but also those Crocs are terrible.
Oh my God.
I mean,
camo Crocs, Rachel? Like, what are you gonna go hunting in those?
I own a pair of Crocs, so I'm not gonna talk shit on Crocs. They are actually for what they are, they're quite comfortable.
It's an abomination to the human foot. Like it is one of the most disgusting, ugliest things ever created. Like
Matt, what were the shoes that you bought from across the street that you used to own here?
Howitzers?
Yeah, I think those are probably an abomination.
Those are, I mean, I bought those because the box said "We the People" and it said howitzers, and then on the inside it said "Made in China" in giant letters. Like it was just the most American thing I think I could have bought, right? But yeah, I think Crocs are definitely number 1 most hated shoes worldwide.
That's for sure not true.
It's definitely not true. If any of our listeners can tell me what is the most hated shoe, you have another free t-shirt coming your way. All right, I'm going to introduce an off the cuff segment, which is the employee gets to ask the boss a question live on air, if we're on air. So, Wesley, I'm going to put you on the spot. What's a question that you want to ask Matt that you think listeners should know about AstroForge?
We can edit out all your downtime while you think about it.
He's
and
contractually obligated to answer.
keep in mind, I'm not contractually obligated to keep you here.
How often do you come to the structures team just to annoy us?
Oh,
Same, I go to all the other teams.
so at least once per day?
Oh yeah, at least.
Yeah.
I think the structures team right now does not have a head. So as an individual, I will walk around and talk to everybody. And I think that's an important part of it. I need to understand, just like everybody does, including Robin, about what is going on in the intimate details of the spacecraft. And the best way you learn what's going on in the spacecraft is actually just go talk to all the engineers. Like we could have a management meeting and have all the managers in a room and be like, hey, what's going, you're going to get a level removed or even 2 levels removed in some cases of the information. When I want to know what our fundamental frequency is, I go ask the person doing the study on the fundamental frequency, right? And I think you've seen this in some ways. Having this high-level view can be extremely helpful to question things that could be wrong. For instance, the solar panels, right? Let's just looking at them and saying like, when was the last time we looked at just using carbon fiber sheets? And you were like, well, I don't think it's going to make it. I was like, can we just do the math and see? And it ends up like, oh, actually, that's a much better use case. We had the same thing with the antennas. And I think the reason that I can do that and bring this up is it's not because I'm fucking special. It's because I'm actually extracted from it for a long period of time. And I can come in and just be like, why was that decision made? And a lot of these decisions aren't made at one point in time. They're made early. They think it's the better process. And then they steamroll into like tunnel vision and going down the road. We've had this happen. We even had this on the solar panels with the breakup of the strings, right? We had 4 strings on the solar panel, which meant we would build 2 different disparate types of solar panels. And when I asked you why, you said, well, the head of avionics wanted this. And when I asked the head of avionics, he said, well, the solar panel guys wanted this. And I'm like, can we just both talk to each other? Like, oh, wait, we actually don't want this. Let's go to 6. That makes a lot more sense. And we're back to one side. So that is why you see me come around and ask, not just you guys, but all the team, what they're doing, what they're working on, and trying to get a better sense of what's going on at the company.
Cool. All right. Well, then we're going to go into mailbag quickly. We've got one actually.
Hold on. We haven't asked this in a while. Like, how many people in Kenya are listening to us, right, Joe?
It's not even showing up on the stats portion.
Oh, you
Yeah,
lost
we
Kenya.
We lost Kenya? Damn.
The
That's
second runner-up country
Russia or China?
is Germany.
Oh,
Germany.
Yeah.
All right.
Okay.
Shout
How many
out.
people listen to this podcast? Like, are we above 10?
We're definitely above
We're
10.
definitely above 10.
I'm going to say we're above 10. And actually, like, this might be the first time that we have a topically relevant mailbag question.
oh,
Oh, what is that? What is that? What is that? That bump on that graph I'm seeing? How many people's?
So total we have 7,471 individuals.
This doesn't really answer the question, Rachel. How many people listened to the last episode?
The last episode so far is 236.
236 people. Wow, this is depressing. Okay, continue on your question.
I don't think that's that depressing. All right. From Anwar. Can a spacecraft technically pass 5 and still be damaged in ways you don't see until orbit?
yeah, that's called
called Odin.
Oh,
Like, well, that's what fucking happened on Odin, right? Like,
yeah.
I mean, the clear thing that happened on Odin is the panels did not deploy. Now we talk about the spring being there. We talk about the nut. We'll never actually know the root cause, whether it was probably the power system that was not able to charge it up. But like, are things damaged that we can't detect? Absolutely. That's what happens. Every spacecraft has to go through a vibe test. And part of that vibe test is the functional test to make sure it works after. What is it? Something like, there's a really high number of spacecraft that die on orbit. And I think it's upwards of 40% on launch in LEO. It's like an extremely high number when you go look this up. I'm probably wrong, and somebody will probably write me that I'm wrong.
Absolutely. I can't wait for
You
the
know what?
fact check emails on this. It's my newest favorite segment of this, which is we haven't made it official, but people just fact check you. And
Yeah, I know.
It's great.
You should start
yeah.
saying more absurd numbers.
99% of spacecraft fail on launch. And so because of that, like, and those are all things that are undetected, right? Or if they were detected, you didn't fix them, like, then you're just really stupid. Most of the time, it's just things we didn't know about, and we don't get another shot. It's not like we can, if you build a car in your garage, you get to turn the key, and most of the time it's not going to turn on, but you can go look at it and be like, oh, I forgot to plug that wire in. We don't get that on spacecraft. We turn the key, and if it doesn't turn on, like, it's fucking orbiting the Earth at this point. We got nothing we can do. Or in our case, it's going to deep space.
Yep.
We just wave by.
Yeah.
Yeah. There is also fatigue that can happen if you go through a ton of vibrational tests. That's why you want to keep that number down low. We do try to keep it away from a point where we can get fatigued
Yeah.
over time. However, if we're trying to push margins like we are, there is totally a possibility that you can start to fatigue and have micro cracks,
Yeah.
micro fractures that can lead up to something damaging in the future.
And when you say fatigue, do you think about that as only the primary structure, or is that actually spread across all of the different materials that we're using on the spacecraft?
It could go through a multitude of things. You could have problems with solder.
Yeah.
I think the primary structure is probably the least fatigue I'm worried about, to be honest with you. It's a lot of the avionics boards can
Yeah.
show cracking. Solder can break off. And like that little thing, if a CPU just loses a couple pins, like
Yeah.
spacecraft done. I mean, that's why we functional check, right? Because we
Yep.
can't analyze every single PCB at that level. We have to test it going through this.
Yeah, and we do a functional test at the Cape right before we integrate to make sure that everything seems like it's working.
Yeah. Cool. All right. Well, I think that's a wrap for vibe testing today. Thank you very much to Wesley for joining us, putting up with all the shenanigans on this. If anybody has any questions about test validation or anything like that, please email them into mailbag@AstroForge.
And if you want to sponsor Wesley's Spikeball Pro Team, because I'm sure as hell not, what's the email, Wes?
Thegoatgene@gmail.com.
Say that one more time.
Thegoatgene@gmail.com.
Wait, is that your real email? Is that what your shirt means?
That would be
That's
the
your
shirt.
team?
Yeah, that's the team.
All right. Rachel will link it in the podcast because I don't know how to.
If you build solar panels, please apply it to.
Actually, Matt did say he would sponsor the team if I made it to the national team.
Okay.
That was something that he said like a year ago. I'm
Sounds
sure he
about
doesn't
right.
remember.
I think I said I would personally sponsor a team because I think to personally sponsor Spikeball is like what, $500?
Yeah, probably around.
Okay.
Yeah. that
Jeff's
sounds
also in. We'll put it on there.
I said no such thing.
I heard a chap.
All right. That's a wrap. Thank you all.